Cell phones off.
Excellent question.
It's interesting how many. Welcome everyone. I see some new faces, so I'll just introduce myself, Stephen Hegedus. I'm the director of the Kaput Center. Welcome to people online as well. And we are midway through our interdisciplinary colloquium series. It's a great pleasure for me to introduce Professor Marcia Linn from Berkeley here today. I'm going to give a brief bio and then hand it over to Marcia. Are we doing interactive or deliver a talk and do questions and answers after? I didn't.
Oh, interactive. Please ask questions anytime. Sometimes people say that I speak too fast, although of course I deny that. But that's always a good reason to slow me down. But also, I can't read your minds, and so you will have to ask questions in order for me to meet your needs.
Okay, great. And I know there are some students here who have to step out in an hour's time, so they apologize in advance. They have to. What do you have to do? Go to class, that's right. Important details, right? Dr. Linn directs one of the 13 centers for learning and teaching funded by the National Science Foundation, Technology Enhanced Learning in Science TEL Center. A fellow of the American Association for the Advancement of Science, she investigates science teaching and learning, gender equity, and design of learning environments. In 1998, the Council of Scientific Society Presidents selected her for its first award in educational research. Since 1995, from 1995-96 and 2001 to 2002, she was a fellow at the Center for Advanced Study in the Behavioral Sciences. In 1994, the National Association for Research in Science Teaching presented her with its award for lifelong distinguished contributions to science education. The American Educational Research Association bestowed on her the Willerstein-Godsell Award in 1991 and the Women Educators Research Award in 1982. Twice she has won the Outstanding Paper Award of the Journal of Research and Science Teaching. She has accepted invitations to contribute as a Fulbright professor at the Weizmann Institute in Israel, as a visiting fellow at University College London, and as a visiting fellow at the Institute, the J.W. Rousseau in Geneva in Switzerland, where she worked with Jean Piaget, someone you may have heard of. Her board service includes the American Association for the Advancement of Science, the Graduate Record Examination Board, again a board that many of you are familiar with, of Educational Testing Service, the McDonald Foundation Cognitive Studies, and the National Science Foundation. Her publications include Computing Teachers, Peers, Science Learning Partners, and many others. One of this year, just giving a plug, and latest book of many is out by Routledge, Science Learning and Instruction, Taking Advantage of Technology to Promote Knowledge Integration. I think we should be pointing at some of the work in here today. And I realise we don't have this in our library, so I'm going to fix that in the next 5 minutes. Okay, so welcome, Marcia. It's a great pleasure and honour to have you here at the Kaput Center. I've been waiting for you to come for a while, and I'm going to hand it over. Technology Enhanced Inquiry, Teaching and Learning in Science. And it's great actually to see, I know many of you are science teachers here today. I'm not here purposely, so welcome. Thank you.
Well, thank you very much. Thank you for the lovely introduction. It's very fun to be here. I've had a great time so far learning about what's going on here. It's a very vibrant center. I'm also kind of honored to be here because Jim Kaput was really a dear friend of mine and a very important mentor and colleague. And my talk about inquiry today is very much related to our shared interest in making science and math both more personally relevant and something that you could do for the rest of your life. I used to argue with Jim because I thought it was somewhat unfair that you taught people math and they got to use it, at least occasionally, almost every day. We teach people science and they at least deny using it ever again after they finish their science courses. So I'm kind of excited to think about how we could merge math and science in hopes that people would use both every day. Also, of course, one of my reasons for being interested in inquiry is trying to get kids to inquire about contemporary problems. So all of the materials that I talk about we really connect the science to something that students care about, heat and temperature, to whether you can survive in the wilderness. We're going to be talking about chemical reactions a little today, and we connect it to hydrogen fuel cell cars and to global climate change. So one of the goals of the materials that I've studied is really to help students bridge everyday and science topics in the classroom. And that kind of brings me to our thinking about how people learn, because we found that if you ask kids in science class about a topic, they may not have many ideas. But if you place the topic in the context of an everyday experience and say, well, you know, what do you know about heat and temperature, for example? You know, what do you know about keeping warm and keeping cold? Suddenly they have a whole bunch of ideas, which are often contradictory and inconclusive and unconnected. And so another goal of our work in inquiry has been to get people involved in this whole process of just sorting out their own ideas and paying attention to the evidence that they're currently using to support their views. So I was mentioning at lunch that when we first started with thermodynamics, students would tell me, well, you know, they didn't believe in thermal equilibrium at all because, you know, metal felt cold and chairs felt warm, and, you know, it wasn't possible that everything was really at the same temperature in the room. And furthermore, since metal felt cold, it had this wonderful property of imparting cold. So if you wanted to make things cold, you should wrap them in metal. And they were very dissuaded by the idea that you might wrap something in your sweater, because they thought that would just warm it up. So students bring these ideas. They're funny and they're kind of cute, but they're also representing serious science thinking. I mean, they're taking evidence and putting it together and coming up with ideas that we wouldn't say are normative, but they're good ideas in the sense that they have scientific reasoning behind them. And so one of our goals in promoting inquiry has been really to pursue this process, to support people in doing this whole thing of taking the evidence that they have, maybe more evidence that we give them, and sorting it out and coming up with better understanding of the science that is being taught. So I'm going to talk today about various ways that we could do that. And because assessment is so important, I'm going to actually link kind of the instruction and the assessment and show you how they could be integrated as opposed to disjoint. This interest in inquiry has luckily been joined by Doonesbury, which I'm quite relieved about, because we definitely need people to help. And Doonesbury has really satirized the new approach to assessment. So Zip's saying, sure, I could go the rote route, but why would I? Ask me a question, any question. When is Guy Fawkes Day? November 5th, 0.08 seconds, etc. So basically illustrating the fact that if you just have Google, you can answer almost any question. Do you want me to read the rest of them? The seventh most abundant element in the Earth's crust, the three main branches of moral philosophy, etc. So, and then, of course, being Doonesbury, it goes on to, wow, you're right, search is a lot faster than trying to remember, and more accurate, which raises profound questions about what it means to be a student. Yeah, like why go to college? Well, the party, that hasn't changed. Don't overthink this. But I think if we made the case for inquiry in science, we might have another reason to go to college. Unfortunately, the kinds of assessments that Doonesbury is satirizing are alive and well in our state and national tests. This is an example from the California assessment. It's used in the districts to basically grade individual students and teachers. And it's definitely one of those items that if you had Google handy, you could answer more easily. Which of the following best describes an atom, etc. You can decide which answer you prefer. Similarly, I recently looked online at the kinds of questions that textbook publishers provide for clicker activities. Now, you may be encountering in your classes much more sophisticated clicker questions, but if you use the ones in the textbook as an instructor, it's probably not a good idea, because this is the same sort of thing. In one cycle of lunar phases, each crescent and gibbous phase has a duration of about 1 hour, day, week, month, year. And then we find that only 20% of the students get it right, so that's reassuring. Well, this is just an example from the textbook. So as you saw, Batsheva and I went through the literature and really tried to figure out what are the factors that support inquiry